Today we're going to talk about volume of cones. So as you can see, the picture of a cone, this one is kind of standing up with a point on the top. We see cones in ice cream cones. We see cones at the top of pencils where the point for the lead would come about. So you can see the cone has a little bit of a similar shape to the cylinder that we just talked about, with the major difference being it does have a base of a circle, but it doesn't have two circle bases. It only has the one circle base. So in the cone, we talk about this point up at the top as the vertex. The height of our cone is going to be the distance from that vertex point straight down to the perpendicular line that would form at the base of the circle. So over here you have this is called an oblique cone, where it's not perfectly straight up and centered over the base, but it's still going to be this distance coming down, which is actually inside the cone, that's going to create a 90-degree right angle with the base up to the vertex. Okay, so when we talk about the height, just like in the cylinder, it's the distance between the vertex and the base, not one of the sides going up on these like diagonals right here. Okay, that's something different. So the first thing we want you to notice is in this looks a little bit similar to the cylinder formula we saw yesterday, where we had that big B, which was the area of the base times the height. Obviously the difference is we have this 1/3 in here. Basically what this is telling us is that a base that's the exact same for a cylinder and a cone, if it has the same height and the same base area, there are 3 cones that would fit inside of the one cylinder. So the other thing I want you to notice here is, we said yesterday, the better formula that we're going to be using is we're going to change, because the bases are still circles, we're going to change that big B into the area of a circle formula, which is the pi r squared, and then the h. So this is the formula that we more often use when we're working on these. 1/3 big BH is the same thing, but the one that I just drew shows you more specifically what we need. We need the radius, we need the height, and then we need to figure out if we're using pi or the pi button 3.14 or the pi button on the calculator. So let's just go through a few. It's very similar to what we talked about with the cylinders. You're going to look at the information you have, plug them in, make sure we're using our order operations correctly, and then remembering we're rounding to the nearest whatever, tenth, hundredths, whole numbers, and then make sure we include labels. So here's number 1. So find the volume of the cone. So again, looking at this cone, we have some information. We do have the height. So the height is this distance from the vertex down to the base, causing this right angle. We know the height is 6. The radius we don't have yet, because we can see this line is actually a 4. That's the diameter going all the way across. So we do know that we can figure out the radius pretty quickly by dividing the diameter in half. So here we go with this. So we're going to do, and I'm going to leave this 1/3 as a fraction for now, and then we'll deal with it from there. Then I am going to turn the pi into 3.14. The radius we just said was 2, and the height we said was a 6. So it looks like a lot going on there, but let's just leave the 1/3 for the moment and figure out the rest. So again, remembering order of operations, the very first thing that we do is we take care of the exponent. So my next line should really look like 1/3 3.14 times 2 squared is 4 times 6. Then we see a whole bunch of multiplications. So at this point, I think the best thing to do is just to multiply everything except for the 1/3 for the moment, and I'm going to explain why in 1 second. We're going to do 3.14 times 4 times 6. And when I do that, I'm going to get 75.36. Okay? Now, 1/3. So 1/3 being a repeating decimal, it's a little bit tricky in the calculators. They don't all deal with them as well as they should. The other thing we can think about, though, is instead of trying to turn this into 0.3, which it's really not, it's 0.3 repeating, the other thing to do is when I multiply by 1/3 as a fraction, that's the same thing as saying divide by 3. So with that in mind, that's why I left the 1/3 for the very end. At this point, I'm just going to say divide by 3, and my answer is going to come out to 25.12. Now, it says round to the nearest hundredths. Well, we already have it to the 100ths, so I can just leave it this way. This is 25 and 1.12. And we're talking about meters, and volume is always cubed. So there is the volume, it's 25.12 meters cubed. Next one. So we have a cone. Now it's on its side. We don't want to get confused by that. Again, remember the height is the distance from the vertex to the base. So it's not that it's always a height, meaning it's straight up in the air. But this time we don't know what this is. Lucky for us, we do know the radius, the 9. We also know the volume. So because of that, I can plug in what I have. I have the volume, it's 956. We're going to do 3.14. I have the radius, and I don't have the height this time. So always plug the formula in to show what you have to then solve backwards to see what we need. So obviously we need to isolate the h and get that all by itself, which is going to take a little time first. First step, we know we're going to do our exponents. So the 9 squared becomes 81. And then everything else comes down in weights. I'm again going to leave, for the moment, the 1/3. Okay, and we still have the h kind of here attached. So then, when I do 81 times 3.14, I get 254.34. Still 1/3, 956. Now, times 1/3 really means divide by 3. That's going to give me 84.78 h. Now we know that at this point we have multiplication on the right, and we can undo multiplication with division, and that will cancel. So I'm going to take my 956, divide it by 84.78, and it's going to give me 11.27. And I'm going to stop there because up at the top it says to round to the nearest tenths. So when we round to the nearest tenths, I need to use the 100ths column to do it. The hundredths obviously is the second one after the decimal point. Being higher than 5 means that I'm going to round up. So my height is 11.3. We're dealing in feet this time. And because it's a single measurement, it is not squared or cubed. It is just 11.3 feet. On this one, we're now finding the radius. So again, looking at the information we have, we do have the volume, which is 80. We do have the height. But what we don't have is the radius. And I think the other thing that we always have to make sure we do is that we remember that square. I think sometimes that square can get lost in the formula. When we get to our answer, we're rounding there as tenths. So again, we need to go out to the hundredths only to then round up or not round up. So as I start running through my numbers, what I'm going to do is take the 9 and multiply it by 3.14, which is 28.26 r squared equals 80. The other thing I can do at this point, instead of now dividing by 3, the other way I can move this is I could divide both sides by 1/3. So when I divide by 1/3, remember that means I take the reciprocal of 1/3, which is a positive 3, and I change division into multiplication. So I'm just going to do that on this one, just so you can kind of see how there's other way to do this. Right? So what I would do is I would divide by 1/3. And again, 80 divided by 1/3 turns into 80 times 3, which is 240. So it kind of, another way to do it, if that's something that you can understand and like, certainly feel free to use it. I still have to deal with this kind of decimal on the other side, but now I can divide 28.26 from both sides. Now when I take 240 divided by 28.26, I get 8.49 equals r squared. So unfortunately, it's not a nice number. I'm basically just going to be using the calculator to kind of figure out this answer. But when I plug in and I take that square root of 8.49 is 2.91. I don't need to go any further. That will now give me the r. Rounding there as tenths means it's going to be about 3. But we'll leave it as that since they wanted the tenths, and we are dealing in inches, so it's about 2.9 inches. 2 points. My box took away the point. And then last. So when I look at this one, we have to answer a trivia question before the sand and the timer fall to the bottom. So what we have to look at is we have to find the volume of the sand. So the sand, which is this kind of reddish looking stuff, is in this cone up at the top. This would be a cone. And we're not using the entire cone way up top. What we're doing is we're looking at the amount of sand. So the sand is actually sitting here. So what we have to do is use the volume of a cone without worrying about this number. This number would be as if the sand was all the way up to the top and filled with sand. Our cone is stopping there. And this is the amount of sand that will run out if we don't answer it in time. So this would be one of those where this number up top is something that we don't really need. Okay, we're more concerned with the numbers below. Okay, so first let's find the volume of the sand that we have in the timer. So the volume is 1/3 pi. Our radius is 10. Our height is 24. Okay, so we have 1/3, 3.14. 10 squared is 100 times 24. If I do 24 times 100 times 3.14, I get 1/3 times 7,536 times 1/3 is divided by 3, which means the volume of the sand is 2,512 cubic millimeters. So again, that's not the amount that could fill this timer. It is the amount that we have in the sand only. So now the question doesn't ask how much volume of sand do we have. It asks how much time do you have to answer the question. So this is where we go back up into the problem. We were given this information right here, is that every second that goes by, we lose 50 cubic millimeters out of this amount as it's dropping down. So we're going to use a proportion to figure that out. So what we do is we would look at that first one up at the top. We said we had 50 cubic millimeters per 1 second. And we need an equal ratio on the other side. We're going to use our 2,512 cubic millimeters per x seconds. Well, that's what we're looking for. We don't know how long that's going to take. So this is where, when you solve your proportions, you would do your cross products. You would do 50 times x to get that first one. You would then do the denominator times the other numerator. 1 times 2,512 gives me 2,512. Then I would say I'm going to divide both sides by 50 to undo times 50. And that is going to give me x as my final answer equals 50.24 seconds. So I have just over 50 seconds to answer the question, or else the sand is going to run out of the timer. So just like the cylinders, basic thing is just make sure you have the correct formula, 1/3 pi r squared h. Fill in your numbers correctly to the right spots, especially if you have a diameter. Make sure you make it the radius before you plug it in. Follow your order of operations correctly, obviously doing that exponent first. Any kind of inverse operations to solve if you are looking for the r or for the h. Should be pretty well done. Make sure you're thinking about your rounding correctly. If you have any kind of questions, feel free to let me know, and we'll talk to you again soon.